NOR gate, okay, write this somewhere, okay, that single input NAND or single input NOR gate. Then I will be continuing with the topic again. Okay, so just solve this and let me know what is the solution that you get here. Well, if I say that this is my input A and this is my input B, can you find that this is what? This is my NOT gate. So what will be the output? The output will be A naught, okay, A bar. And if this is bar, so after passing through the NOT gate, what will be the output here? The output will be B naught. And what is this? This is my, try to say, is this my AND gate? No. Is this my OR gate? Because it is having a curved opening? No. It is a NOR gate. Why? Because you can see the circle over here, which means that this is not. Okay, this is NOR gate. Okay, so NOR gate means that the input is A naught and B naught, and what is the output? The output will be OR not, OR and not. That means A naught plus B naught whole naught, A naught plus B naught whole naught. So what can I say here? That my output is equal to A naught plus B naught whole naught. Okay, just use the De Morgan's theory. So I will be writing it is A double naught, it is B double naught, and the symbol between them, which is of addition, turns into multiplication. A double naught is A and B double naught is B, which is equal to A plus B. So basically you can find that this entire circuit is behaving like what? This entire circuit is behaving like the AND gate. This entire circuit is behaving like the AND gate. So if I draw the truth table for this, this is my input, this is my output. Okay, my input for AB, my output for Y is equal to AB. What is this? If I say that my input is 0, 0, output is 0, my input 0, 1, output is 0, my input 1, 0, output is 0, and when it's both 1, the output is high. So this is the truth table for this circuit. Okay, I hope this is clear. Okay, sounds good. I need to take this question, but I think that this is not the correct moment for this. Okay, let us take few more theory segment and then we'll be continuing with this. Okay, so this was all about your OR gate and NAND gate. Okay, now let me ask you, okay, now let me take you to the special gates. What are the special gates? If you remember, we were having two special gates. One is XOR and the other one is XNOR. We'll be discussing it together. Okay, but for now, let us continue with it. Okay, can I say here that here all the universal gates that I discussed, okay, the AND gate, the NOR gate, and whatever gates, the fundamental gates as well. Can I say that I can convert the two input system into one input system? One input system. Okay, how can you convert a two input system into a one input system? Okay, well, you can do so. If I say that this is my two input system, let's say that I am taking an OR gate. So OR gate is like this. This is two input system. So two different inputs were going through this. Okay, if I say that both of the inputs are same, can I say that this is my two input system just with one? Okay, if I say that earlier A was going from here, earlier B was going from here, if I just connect them and through this I pass a single value of A, so both the inputs will be A. Are you getting this? Okay, this is basically a single input gate. Okay, the single input gate is basically any kind of gate which you can take like that. Okay, any NAND gate or any NOR gate, okay, write this somewhere. Okay, that single input NAND or single input NOR gate is equal to NOT gate. Okay, single input NAND gate or single input NOR gate is equal to NOT gate. How is this possible? Like, how can I say this? Well, I can say this because here, I out carefully. If I say this, can I say here that if I'm taking NAND gate, so the NAND gate will be looking something like this, right? I'm taking a single input one. So if I say that this is a circuit, from here A was passing, this is A, this is A. So Y will be equal to what? This is NAND gate, and NOT. That means A dot B whole bar. Since I know that A and B both are same, can I write that this is equal to A naught plus A naught? Okay, A naught plus B naught. Since I know that A is equal to B only, therefore I'll be writing A naught plus A naught, which is equal to A naught only. So here what you find, that a single input NAND gate is behaving like what? It is behaving like a it is behaving like a NOT gate. What about a single input NOR gate? So if I'm taking a NOR gate, let us say that this is my NOR gate. Okay, and I say that both of the ends are joined. A single input A is being carried here. I will be saying that the output Y is equal to what? So you can see that this is NOR. What is it? This is NOR. So I will be saying that the inputs are being added and then bar over them. So A plus B whole bar. I will be writing that this is A naught B naught multiplied. Okay, according to De Morgan's theorem. So this is equal to A naught dot A naught. Okay, you already know that A is equal to B, therefore, and I can say when both of them are multiplied, the answer remains the same, that is A naught only. So this is the way you can find that single input NAND gate or single input NOR gate is just equal to NOT gate. Clear? Okay. With this, we are done with around two kinds of gate. Okay, we are done with the fundamental gates, we are done with the universal gate. Let us just now have a look on special gates, the XOR and the XNOR. Okay, and after that, we will be taking the questions then. Beginning with the XOR gate. XOR gate. So these are the special gates that I am discussing. So the very first thing, what is an XOR gate? So the XOR gate is definitely a special purpose gate. A special purpose gate. They are just used for a special purposes. Okay, you must know the Boolean expression. The XOR gate and the XNOR gate, they are not so important to you. Okay, just know their expression, just know a bit thing about that, and that is enough for you. Okay, so the expression for your XOR gate is Y is equal to A bar B. Okay, A plus B, like that. Okay, what does that basically means? This means A B naught plus A naught B. Got it? A B naught plus A naught B. Okay, now I think you can make a guess what is XNOR gate. Okay, XNOR gate, if I just write it side by side, XNOR gate, this is equal to the opposite, the inversion of the XOR gate. Okay, so this is also my special purpose gate. Special purpose gate. What is the Boolean expression for this? So the Boolean expression is Y is equal to A over A plus B over bar. Okay, that means you will be writing it as A B naught plus A naught B whole bar. Just solve this. Okay, I guess I have also given you this as homework. Okay, when you will solve this, you will find that this is equal to A naught B plus, okay, A plus B naught. Okay, A plus B naught, and when you will multiply this, what do you get from here? So you'll get A naught plus A naught B naught plus B A plus B naught. This is 0, this is 0. What I am left with? I am left with AB plus A naught B naught. Okay, so if I solve this, I will be getting that this is equal to AB plus A naught B naught. This is my special XNOR gate. Is that clear? So these were about the two gates. Okay, just this. What about the symbol for this? Talking about the circuit symbol, the circuit symbol for XNOR gate is something like this. Okay, clearly two inputs will be there like this. Okay, this is your XOR gate. This is your XOR gate. So what about the XNOR gate? So the XNOR gates looks like this. Okay, this is your XNOR gate. What is this? This is a circuit symbol for the XNOR gate. Okay, what about the truth table? Okay, I think the truth table can be framed from your side, but still I will be doing it for you. Okay, truth table. So let's get into it. So the truth table will include the input, okay, and the output. So what are the inputs? The input are A and B. Okay, I will be finding A naught and B naught as well, and then my final output is what? My final output is A B naught plus A naught B. Okay, what about this side? I will be writing here that my input, okay, and my output. So what are my input? You'll find that here my input are A, B, A naught, B naught, and the output AB plus A naught, B naught. Okay, just check the values. Okay, if this is 0, this is also 0. A naught is 1, B naught is 1. Okay, value will be 0 into 1 plus 1 into 0. Okay, 0 plus 0, this is equal to 0. So here value is 0. What about the second case? If this is 0, this is 1, this is 1, this is 0. This is equal to 0 into 0 plus 1 into 1. This gives me 0 plus 1, that is equal to 1. What about the third one? If this is 1, this is 0, this is 0, this is 1. I will be writing that this is equal to 1 into 1 plus 0 into 0. What does that give? 1 plus 0, that is again 1. And what about the fourth condition? If both of them is 1, so this both are 0. This is 0 into, this is 1 into 0 plus 0 into 1. This gives me a value of 0 plus 0 again, that is equal to 0. Is that clear? Okay, so this is the truth table for the XOR gate. Let us do the same for the XNOR gate. This is 0, this is 0. So what is the output? Not the output. A naught is 1 and 1. So I will be writing 0 into 0 plus 1 into 1, giving me a value of 1. If this is 0, this is 1, this is 1, this is 0. What is the value? This is equal to 1 plus 0 plus 1 dot 0. Okay, the value again is 0 plus 0, this is equal to 0. Okay, what about the third condition? This is 1, this is 0, this is 0, this is 1. So the value here is 1 into 0 plus 0 into 1, that is 0 into 0, again 0. and the fourth one, if both of them is 1, the value will be 0 0. Therefore 1 into 1 plus 0 into 0, 1 plus 0, that is equal to 0 here. Okay, just look at this. Okay, what are the things I can observe? So my observation is that in XOR gate output is high. Output is high only when both the inputs are different. Only when both inputs are different. Only when both inputs are different. Okay, and output is low. Output is low. Okay, when the input is same. When inputs are same. Okay, just look at the truth table. Okay, you will find that here the outputs were same, the input is low. Sorry, the input is same, the output is low. The input is different, the output is high here. Okay, so what are my observation? For XNOR gate, if both the inputs are same, the output is low, and both of the inputs are different, the output is high. Okay, let us make the discussion about the XNOR gate. So what can I write for XNOR gate? Well, when both of the my output is high, output is high when both the inputs are high, when both inputs are same, when both inputs are same. Okay, and my output is low. Output is low when inputs are different, when the inputs are different. So just mind this and note it somewhere that here this is the condition that you finally find from here. Okay, with this we are done with the almost all of the part of this questions. Okay, like all of the theory segment. But again my doubt is like where can I find an XOR gate and where can I find an XNOR gate? So as I have mentioned that these are the special conditions. So special condition where definitely you will find it so hard to know. Okay, well, if I draw a circuit like this, okay, the circuit will look something like this. Okay, this is my input A, this is my input B. Okay, this is a NOT gate. Okay, there is a NOT gate as well. Okay, from here up, just a minute, from here a branch of A will be there. Okay, and the B0 part, they will be multiplied. That is an AND gate is over here, and also there is a part of B. Okay, not B0, it is a part of B. Okay, both of them are multiplied by AND gate, so there is an AND gate, and from that AND gate the products are here to an OR gate. The products are here to an OR gate. Okay, so here you can see that here what is reaching, this is B, this is A0. Okay, and what is reaching here? Here it's A and here it's B0. So what I get here? I get here that A B0 and here is A0 B. What is the final output? The final output is A B0 plus A0 B. Okay, fine, I got this. What about the circuit symbol for the XNOR gate? So that is what you will find that this is almost exactly the same. What is the only difference here? The only difference is that you are putting a NOT here. Okay, so I can draw it in two ways. Okay, the first way is that this is my input A, this is my input B. Okay, not. From here one branch came, this is AND. From here another branch came. Okay, and this is AND. Okay, both of the AND got combined. Okay, from here I finally get an OR gate, and that OR gate finally turned into NOT, and this is the thing I got here. Or instead I know that the formula is simply AB plus A0 B0. So I can be writing here that this is my branch A, this is my branch B. Okay, what is happening here? So I can say, okay, let me bring it closer. Okay, from A a branch is reached, from B also a branch is reached. Both of them NOTs are taken. Okay, these are also multiplied by AND gate, these are also multiplied by AND gate, and the product of both of them is finally added by OR gate. Okay, let me draw it like what is happening here. This is, if A was reaching here, this is A0, this is B, and this is A, and this is B0. Okay, what is reached here? Here A B0 is reached, and here A0 B is reached. Finally I get the value that it is equal to A.
It's not effort, it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.